All right, so today we're going to talk about systems and all the choices that come with it. So one of the things we do in solving systems is we can solve them by graphing. All right, so let's say we have the system and they're both in slope-intercept format. Y equals, let's call it 2x, and y equals negative 2x plus 8. All right, so when we graph those lines, realize this one's starting at 0, 0, and has a slope of 2. So it's going to go up 2, and it's going to go up 2 and over 1. This one starts at 8. All right, that's its y-intercept, but it's going to go down 2, all right, and over 1. All right, so when we do that, I'm going to do it on a computer program to make it clearer for everybody. Desmos.com. So we're going to graph. So I graph y equals 2x. So there's 2x, as I said, start at 0, 0. Next point goes up 1 and over 2, putting us at, up 1 and over 2, puts us there at 1, 2. All right, and then you connect those lines to do it. All right, now we said the other one's y equals negative 2x plus 8. As we said, that's going to start, I'm going to make it a little smaller so you can see. That's going to start up here at its y-intercept, 0, 8. It's going to go down 2 and over 1, and most importantly, you will see they intersect at the point 2, 4. What that means is that's the solution to both equations at the same time. So if you have multiple variables, you need that many equations to solve. All right, at some point in life, you may face a 3-variable system, and then you need 3 equations. For the time being, we have the 2. So 2, 4 solves them both simultaneously. All right, the problem with graphing, all right, so let's say we got 3/5 x minus 1, and let's say we have y equals negative 2x plus 3, okay? 1.50, I wonder if that works for both. 4.5, no, it doesn't. All right, so if I go on that line and I keep going through, 1.50, so if I plug that back in, 4.5 divided by 5, it's 0.9, 0.9 minus 1. No, it's not going to work. All right, so it's kind of hard to see exactly where they intersect. So that's the limitation with graphing. All right, now another aspect of graphing, all right, is when it's not in standard form. All right, so let's say we go back to this. Let's say we're looking at system. Y equals 2x minus 2. All right. I don't want to do that. Okay. And let's say we do 3x minus 2y equals 6. All right. Now, when we do y equals 2x minus 2, all right, we can do that right away. Y equals 2x minus 2. All right. Now, when we graph the other one, 3x minus 2y equals 6, we can use the intercept method. Remember to use the intercept method, we divide by each coefficient. So the coefficient of x is 3, so 6 divided by 3 is 2. So I can graph 2, 0. All right, I can graph 2, 0 on my graph. And then if I want to do, let's see, what would the other intercept be? I take the 6 once again, the constant, and divide by negative 2. And that gives me negative 3. So that means 0, negative 3 is my other point. So if I plot 0, negative 3, that, of course, is my y-intercept. And I plot those. All right. I connect the lines. 3x minus 2y equals 6. Bring 3x over. So now I'm going to have negative 1.5x minus 3. Y equals negative 1.5x minus 3. Goes through those points. Why is that happening? Hold on. 2, 0, yeah. Math real quick. 3x minus 2y equals 6. Negative 2y equals negative 3x. All right. Plus 6 y equals 3/2 x minus 3. What did I graph instead? No, there should be a positive. Sorry. So I'll do that. Yep. Okay, so now I'm good to go, and you'll see your point of intersection is somewhere in this area. Again, you're going to be limited with decimals. Okay, so that leads us to our next method, which is either substitution or elimination. All right. Basically, substitution looks like this. Let's say we got 2x plus 2y equals 38. All right. And then y equals x plus 3. When we're looking for substitution, we're looking for a variable that's isolated. Okay. That's without a coefficient. That's what we mean by isolated. Y equals. Doesn't have to be y. It could be x equals. When we use substitution, what we do is we replace the y with that value. So see how y is equal to x plus 3. Okay. We're going to take, all right, 2x is going to stay the same. And then we literally substitute whatever y is equivalent to into the equation. So the 2x plus 3 is there. All right. I'm going to switch some colors so it's easier to see. I'm going to switch that to the red. Actually, I'm just going to make that green. Make these the yellows to make it easier for people to see. All right, so that's the idea. All right, and that's still equal to the original value, 38. So that's all we're looking at. All right, so now I'm going to distribute like we've been doing all year. 2x plus 6 equals 38. I'm going to collect some like terms. 4x plus 6 equals 38. We're going to subtract 6. 4x equals 32. Divide by 4. Oh, boy. X equals 8. All right, and here's the advantage to substitution. Once you have one of the ones solved for, all right, so in this case, x equals 8, okay, we can go right in now, all right, and it's at our advantage. Okay, we can go right back and replace that up there. All right, so if x is 8, we can go right there and replace that. And when we do, we get y equals 8 plus 3, which is equals 11. And then our solution in coordinate format, the x value was 8, the y format is 11. All right, so that's how we use substitution to our advantage. Another way we can use substitution is, let's see what I got at my disposal. All right, y equals 1/2 x plus 7. All right, and then the next one would be, okay, y equals, what's the other one I wanted to be? 3/2 x plus 3. Okay. Now, one of the things you need to get used to in math is seeing when two things are equal to the same thing. And in this case, y is equal to both. All right. That's not going to help. It's given the whole thing. So the y is the same in both. So what we can do is we can say, okay, when is y equal to y? Well, in the first equation, substitution would be the 1/2 x plus 7. And the second equation would be the 3/2 x plus 3. All right, now, if you don't like fractions, you look at your denominators. They're both 2. So you're going to multiply everything by 2. All right? So you're going to multiply both sides of the equation. There we go. We'll move that there. All right. And that'll get rid of the halves if that's going to bother you. All right, so 2 times 1/2 cancels out. But remember, you're distributing, so don't forget it's also 14 equals 3x plus 6. All right, 14 equals 2x plus 6. Subtract the 8 from both sides. 8 equals 2x. 4 equals x. All right, again, we can go right in and plug it in. If I plug it into this equation, all right, y equals 1/2. But this time, instead of x plus 7, all right, half of 4 is 2. 2 plus 7 equals 9. So I end up with a final answer of x being 4 and y equal 9. All right, so that's what substitution is. All right, the second one we got is elimination. And elimination, literally, you're trying to cancel the variables. All right, so if we're looking at two equations in what we call standard form, all right, so let's say 3x minus 2y equals 0, and then 4x plus 2y equals 14. All right, you'll notice what we have here, all right, what we have here, all right, is two variables that are opposites of each other, the negative 2y and the positive 2y. So what we do, okay, oh boy. What we do is we put a line right underneath. All right, we put a line right underneath and add straight down. And when we do, we're going to add 3x and 4x, and that gives me 7x. And what happens is the negative 2y plus 2y cancels out. We got 7x equals 14, and x is equal to 2. All right, now, the disadvantage to it is it's kind of harder to get the other variable, but it's not a big deal. But again, we're going to substitute back in. So now instead of 3x, it's 3 times 2 minus 2y equals 0, and we're going to solve. 3 times 2, boy. 3 times 2 is 6. So 6 minus 2y equals 0. All right. Subtract 6 from both sides to solve. Negative 2y equals negative 6. Divide both sides by negative 2, and y is equal to 3. All right. Now, if they're not the same, all right, if they're not the same, we look for easy ways to make them the same. All right, so if we got 3p plus 2q equals 7, 2p minus 2q equals negative 6. 2p plus, where would it go? Plus, it should be a q. All right. So what you'll see is we don't have anything that's opposite of each other. However, if I take the original equation up top and multiply it by 2, which I'm allowed to do, as long as I do it to both sides. All right, I distribute through on both sides. 6p plus 2q equals 14. Don't forget to multiply everything. And then the bottom one stays exactly the same. 2p minus 2q equals negative 6. All right. Now I can add straight down. 6p plus 2p gives me 8p. The q's cancel out, so I got 8p equals 8. Divide by 8, and p equals 1. Then I plug it into either equation. If I plug it into the bottom one this time, 2 times 1 would be 2. Minus 2q equals negative 6. Subtract the 2 from both sides. Negative 2q equals negative 8. Divide by negative 2, and q equals 4. So my solution would be p equals 1, q equals 4. All right, I'll try to post another video in the next couple days about what to do when it's not that easy, but at least that should get you started on substitution and elimination. All right. So stay healthy, everybody, and we will see you soon. Make sure you get your work done.